function 5.3, and this is the second objective. In the first objective, we defined the 6 trigonometric functions of any angle. We said that sine theta is y over r and cosine theta is x over r. In objective 2, from this definition, from the definition of sine and cosine, we can talk about the signs of trigonometric functions. Remember that in a plane we have 4 quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. You know that this is the x-axis, and x is positive to the right of the y-axis. So in quadrant 1 and quadrant 4, x is positive. Remember that r is always positive, which is the distance from the point xy to 0, 0. But x could be positive and could be negative. If x is positive, then cosine is positive. So cosine is positive in the first quadrant and in the fourth quadrant. And if cosine is positive, then the reciprocal of cosine, which is secant, is also positive. While to the left of the y-axis, x is negative, so cosine and secant are negative in quadrant 2 and quadrant 3. Also, if you look to y is positive up above the x-axis. So in quadrant 1 and quadrant 2, sine x is positive because sine is x over r. So sine and the reciprocal of sine, which is cosecant, are positive in the second and the first quadrant. But in the third and the fourth, sine and cosecant are negative. Now, what about tan? Tan depends on x and y. Tan theta is defined as y over x. So if y and x are both positive or both negative, tan would be positive. So tan would be positive in the third quadrant and also cotangent because the reciprocal of tan, because in the third quadrant, x is negative and y is negative. So tan theta would be negative over negative, it would be positive. And in the first quadrant, tan and cotan would be positive. So we notice that in the first quadrant, all the 6 trigonometric functions are positive. In the second quadrant, only sine and cosecant are positive. In the third quadrant, only tangent and cotangent are positive. In the fourth quadrant, only cosine and secant are positive. You can remember this sentence: a smart trig class. A, all in the first quadrant. Smart is sine and the reciprocal cosecant in the second quadrant. Trig, tan and cotan in the third quadrant. Classic, C, cosine and secant, the reciprocal, in the fourth quadrant are positive. Let us solve some exercises or examples about this point. Example 3, if tan theta is negative, cosine theta is positive, name the quadrant in which angle theta lies. So theta in which quadrant? Okay. Tan is negative. I know that tan is negative here and here. Tan is negative in these two quadrants. Cosine is positive. Cosine is positive here and here. So quadrant 4 is the only quadrant in which tan is negative and cosine is positive. So the answer, theta, belongs to quadrant 4. Okay, this is the answer of this example. Checkpoint 3, sine theta is negative. All right. Sine theta is negative. Sine is negative here and here because y is negative here and here. Cosine is negative here and here. So sine would be negative and cosine would be negative in the third quadrant. Name the quadrant in which the angle theta lies. Theta belongs to quadrant 3. Please solve this exercise, and this is the answer. Let theta be an angle in a standard position. Of course, theta has to be always in a standard position. Name the quadrant in which theta lies. Okay. Sine is positive here and here. Cosine is positive here and here. So the quadrant in which sine is positive and cosine is positive is quadrant 1. So theta lies in quadrant 1. Cotan is positive and secant is negative. Cotan is the reciprocal of tan. Tan is positive here and here. Secant is the reciprocal of cosine. Cosine is negative here and here. So the quadrant in which cotan is positive, secant is negative, is the third quadrant. So theta here belongs to quadrant 3. Another type of examples. Given tan theta is negative 2 over 3. So tan theta is negative and cosine theta is positive. Find cosine theta and cosecant theta. All right. First thing, I need to determine theta, where, in which quadrant. So tan is negative. Tan is negative here and here. Cosine is positive here and here. So the only quadrant in which tan is negative and cosine is positive is quadrant 4. So I know now that theta belongs to quadrant 4. Okay. In quadrant 4, x is greater than 0 and y is less than 0. And I always know that r is always positive. Okay. Now, what is the information given in the question? He told me that tan theta is negative 2 over 3. I know that tan theta is defined to be y over x. That's the definition of tan. And tan is negative 2 over 3. Okay. Now, should I take negative with 2 or with 3? Let us go back here. X is positive. X is positive, so it should be 3. Y is negative, so I'll take negative with the 2. So x is 3 and y is negative 2. And now I can find r. R by definition is the square root of x squared plus y squared, which is square root of 13. Now I have x, y, and r, so I can find the 6 trigonometric functions of theta. For example, cosine theta is x over r, so it is 3 over square root of 13. And if you multiply by square root of 13 to rationalize the denominator, this would be your answer. Cosecant theta is the reciprocal of sine. Sine is y over r. So cosecant would be r over y. R is square root of 13 and y is negative 2. So this is cosecant theta. Another question. This is similar exactly to this one, okay? Just the cosine here is negative. So we would be here or here in the second or the fourth. So theta here would be in quadrant 2. And in quadrant 2, x would be negative, y would be positive. This is in quadrant 2, this angle. Okay. Now, tan theta again is negative 1 over 3 and it is y over x. X is negative in this case, so I take the minus sign with the 3. Y is positive, so I take it 1. So x is negative 3, y is 1. And r would be square root of x squared plus y squared. So it's square root of 9 plus 1. So it's square root of 10. I have x, y, and r. I can find sine theta. Sine theta is y over r, so it is 1 over square root of 10, or multiplying by the conjugates, it's the square root of 10 over 10. Secant theta is the reciprocal of cosine, which so it is r over x. R is a square root of 10, x is negative 3, so that's the answer. This is secant theta. Another example. Tan theta is positive. If tan theta is positive, then theta is here or here. Sine theta is negative. If sine theta is negative, so we are here or here. So the only quadrant that satisfies the two conditions is quadrant 3. So theta in this question is in quadrant 3. In quadrant 3, x is negative and y is negative. Now he says to me that tan theta is 2 over 3, but I know that tan theta is y over x. So I cannot take y 2 and x 3 because y is negative and x is negative. So I take y to be negative 2 and y to x to be negative 3. Now negative 2 over negative 3 would be 2 over 3. So y is negative 2 and x is negative 3 because x and y should be negative because theta in the third quadrant. And now I find r square root of x square plus y square root of 13. So now I can find cosine theta. Cosine theta is x over r, or if you multiply by the conjugate, it would be like this. And cosecant theta is the reciprocal of sine, so it is r over y, so it is square root of 13 over y, which is negative 2. So this is cosecant theta. Some more examples. Find the exact value of each of the remaining trigonometric functions of theta. One is given, so I need to find the other 5. He told me here that theta is in quadrant 3. If theta is in quadrant 3, then x is negative and y is negative. He told me that cosine theta is negative 3 over 5. But cosine theta, I know that it is x over r. I know that r is always positive, so it would be 5, while x could be negative, and in fact, in this case, it is negative. So I take the minus sign with the 3. So this means that x is negative 3 and y is, and r, sorry, is 5. I need to find x. So I know that r square equals x square plus y square. So 25 equals 9 plus y square. So y square would be 25 minus 9, 16. And now y would be square root of 16, which is 4. But is y positive or negative? Y should be negative. So I take the minus sign. So here, y square equals to 16. The answer of this equation would be y could be plus or minus square root of 16, which is 4, but y here has to be negative, so I take it negative 4. So I have x, r, and y, and I can write all the 6 trigonometric functions of theta. I know cosine, the reciprocal of cosine is secant, so secant is negative 5 over 3. Then I need to find sine. Sine theta would be y over r. Cosecant theta would be the reciprocal. Tan theta would be y over x. So it's 4 over 3. And cotan theta would be the reciprocal. So it would be 3 over 4. So this is the answer. Another question. Sine is 5 over 13. Theta is in quadrant 2. In quadrant 2, this is a quadrant 2. X is negative and y is positive. Okay, what do we have? Sine theta is given. What is sine theta by definition? It is y over r. So y over r is 5 over 13. R has to be positive, and in this case, y is also positive. So y is 5 and r is 13. Now, how to find x square? X square is y square, sorry, r, because r is the largest one. It is r square minus y square. So it is 169 13 square minus 25, and 169 minus 25 is just 144. So now x square equals 144. So x could be positive or negative square root of 144, which is 12. Now let us look to the question. X is what? X is negative. Since x is negative, I put a minus sign here. Now I have x, r, and y, so I can find all the 6 trigonometric functions of theta. I have sine, so the reciprocal is cosecant, and cosine theta is x, negative 12 over r, which is 13. The reciprocal of cosine is secant theta. Tan theta is y over x, and cotan theta is the reciprocal of tan. Another question. Well, here he did not tell me the quadrant. He told me that tan theta is negative and sine theta is positive. So I have to think, where is theta in which quadrant? Sine is positive, so it is here or here. Tan is negative, so it is here or here. So it is in quadrant 2. So the only quadrant that satisfies both conditions is quadrant 2. In quadrant 2, x should be negative and y should be positive. And please continue like before and find the 6 trigonometric functions of this angle. Let me solve this one. 33. Secant is negative. Okay, secant is the reciprocal of cosine. Cosine is negative here and here. Tan is positive here and here. So this angle is in quadrant 3. Now in quadrant 3, x is negative and y is negative. He told me that secant theta, I know that secant theta is the reciprocal of cosine. So it is r over x, because cosine is x over r. Now, it should be negative 3 over 1 or 3 over 1, because negative 3, you can write it 3 over 1. But r is always positive, so I will take it 3. And the minus sign, I will take it with the denominator. So x would be negative 1, and this is what we need because x should be negative. So everything is fine. So x is negative 1, r is 3, and I need to find y. Y square is r square minus x square. It is 9 minus 1. It is 8. So what would be y? Y would be plus or minus square root of 8. Since y is negative, I take the minus sign. So y is negative square root of 8 or 2 square root of 2. Now I have rx and y. I can find everything. Secant is negative 3, so I will find the reciprocal of secant, which is cosine. So cosine would be 1 over negative 3. And I find sine. Sine is y, which is negative 2 square root of 2 over r. And the reciprocal of sine cosecant would be negative 3 over 2 square root of 2. If you multiply by square root of 2 to rationalize the denominator, you will have negative 3 times square root of 2 over 2 times 2, which is 4. And tan theta is y over x. So it is negative 2 square root of 2 over negative 1. So it is 2 square root of 2. And cotan theta is the reciprocal. So it is 1 over 2 square root of 2. If you multiply by square root of 2 over square root of 2, you get square root of 2 over 4. So this is all about how to find the sign of the six trigonometric functions and how to use this information, uh, a smart trig class, to solve these questions. Let us talk a little about objective 3, find the reference angles. This is very important objective. In fact, this is the most important objective in this section, reference angles. We will often evaluate trigonometric functions of positive angles greater than 90 and all negative angles by making use of positive acute angle, and this positive acute angle is called reference angle. So he says here, uh, to evaluate, to find the six trigonometric functions of angles greater than 90 or negative angles, we will use reference angles. So what is the definition of a reference angle? Theta, a reference angle, is let theta, let us start by here, let theta be a non-acute angle. So it would be, this is theta in the second quadrant, or in the third quadrant, or in the fourth quadrant. Of course, it has to be in a standard position, lies in a quadrant, one of the quadrants. Non-acute, so he is not considering the first quadrantal angles. Okay, it's reference angle. So the reference angle of theta is the positive. So the reference angle has to be positive. It cannot be negative. It has to be acute. So the reference angle would be acute angle. And remember, acute less than 90. So first condition, it has to be positive. Second condition, it has to be acute. Theta prime. So we will call it theta prime. Okay, formed by the terminal side of theta and the x-axis. So this is the third condition. This angle theta prime is formed by the terminal side of theta and the x-axis. Okay, look here. This is the angle theta. Where is theta prime? This angle. This angle is theta prime. Is it positive? Yeah, it has to be positive in this direction, in the positive direction. Is it acute? Yes. This angle, this angle is less than 90. It is between the terminal side and the x-axis. Okay, we have another angle, theta itself is between the terminal side and the positive x-axis, but it is not acute. So theta prime here is the reference angle. If you know theta, how to find theta prime? Theta prime in this case would be 180 degrees minus theta. So for example, if theta is 130, okay, then it would be in the second quadrant, and theta prime in this case would be 180 minus 130, so it would be the angle 50. So this would be 50 and this would be 130. Okay, let us check angles in the third quadrant. I need an angle, positive, acute, between the terminal side and the x-axis. So this angle would be the reference angle of theta. So theta prime is called the reference angle of theta. If theta, for example, here is 250, for example, okay, 250, then how do we find theta prime? 250 minus 180. 250 minus 180. So theta prime would be 250 minus 180, 70. Okay, so theta prime would be 70 and theta would be 250 in this case, theta prime, the reference angle. What if theta is an angle in the fourth quadrant? In the fourth quadrant, like for example, theta is 320, for example, greater than 270. Okay, if it is 320, then how to find the reference angle? It is this angle, the angle between the terminal side and the x-axis, such that it is positive and acute. So how to find theta prime in this case? 360 minus the angle. So 360 minus 320 is 40. So the reference angle of 320 is 40 degrees. Let us solve some exercises. Find the reference angle theta prime for each of the following angles. This is how the question comes. And to answer this question, I need first to sketch the graph of this angle in a standard position. And if I sketch the graph of this angle in a standard position, I put the vertex here and the initial side here, and I go in the positive direction. This is 270 and this is 360. So 345 is less than 360. So this would be 345. This angle is the angle theta. Now, how to find the angle theta prime? The angle theta prime, which is this angle, would be 360 minus 345. So it is the angle 15. It is positive, acute between 345 and 360, between the terminal side and the x-axis. Another question. Theta is 5 pi over 6. And the question, find the reference angle. To find the reference angle, I need to sketch the graph of this angle in standard position. This is a positive angle. So the vertex would be here. The initial side would be here. And I'll go in the positive direction. Now the denominator is 6. I know that here I have pi. And pi is 6 pi over 6. 5 pi over 6 is less than 6 pi over 6. So it would be somewhere here. So this is the angle 5 pi over 6. Now where is the reference angle? This is the reference angle. This is theta prime. How to find theta prime? It is 6 pi over 6 minus 5 pi over 6. So it is pi over 6. So the reference angle of 5 pi over 6 is pi over 6. Another angle, another question. Negative 135. Okay, to find the reference angle of negative 135, I start by graphing this angle in standard position. The vertex is here, the initial side is here, and now I have to go in the negative direction. I know when I go in the negative direction, this is negative 180, and this is negative 90. Negative 135 would be somewhere here. So this is the angle theta, or negative 135 degrees. Now, where is the reference angle? It is this angle. This is the angle theta prime. How to find theta prime? I can start from negative 135, or if you want to forget about the negative, you can find 180 minus 135, and the answer would be 45 degrees. So theta prime is 45 degrees in this case, and that's the reference angle of negative 135. It is positive, it is acute, and it is between the terminal side of negative 135 and the x-axis. Another question. Notice that this is 2.5. There is no small square here, so this is in radian. So 2.5 radian. Okay, I need first to draw this angle in standard position. Now, to draw this angle in a standard position, it's a positive angle. I put the vertex here, the initial side here, and I go in the positive direction. Well, what is pi? If you ask for pi in the calculator, pi is 3.14. So this is 3.14. What about pi over 2? If you divide by 2, you will get 1.57. So this is 1.57 radian. This is 3.14 radian. So 2.5 radian would be less than 3.14 radian. So it would be somewhere here. So this is the angle theta. and it is 2.5 radian. Now, where is the reference angle? It is this angle. So this angle is the reference angle, theta prime. And by definition, theta prime is 3.14 minus 2.5. So the angle would be, or you can say pi minus 2.5 if you need the exact answer, or it is 0.64 radian. This is the reference angle of 2.5. Please solve this checkpoint. Similarly, I will help you maybe by solving part D, okay, 3.6. I will solve part D and I will leave all the others for you. First point, I need to sketch the graph of theta, okay? This is 3.6, so again it is in radian. Well, I know again that pi is 3.14. Okay, what about 3 pi over 2? 3 pi over 2 is 4.71. So if you sketch the graph of this angle, if you put the vertex here and the initial side here, and you go in the positive direction, 3.6 is greater than 3.14 and less than 4.71. So it's somewhere here. This is 3.6 radian. So this is the angle theta. Now, where is the angle theta prime? It is this angle. So theta prime, how to find this angle? I have 3.6, which is greater than 3.14. I subtract them, and the answer would be 4.46 radian. So this is the reference angle of 3.6. Please also solve these exercises similarly. And here, find the reference angle of, let me solve 44 for you. Please try 40 by yourself. It is all the same idea. To find the reference angle of 5 pi over 7, as usual, I need to sketch the graph of this angle in standard position. Okay, it's a positive angle. So the vertex is here and the initial side is here. And I go in the positive direction. This is 5 pi over 7. So this is pi. Pi would be 7 pi over 7. So 5 pi over 7 would be somewhere here. So this is 5 pi over 7. It is less than 7 pi over 7. So this is the angle theta, and this would be the angle theta prime. So how to find theta prime? It is 7 pi over 7 minus 5 pi over 7. So it is 2 pi over 7. Please also solve this question. And I stop here. And next time, inshallah, I continue this objective. If you have any question, please